Hey guys, welcome to Getting Geography Series Episode 3, where I'm going to continue talking about elements of weather. This time I'm going to focus on clouds and rain. So what are clouds? Clouds are essentially visible masses of water droplets or ice crystals that are suspended in the atmosphere. So actually, there are many different clouds at different altitudes. For example, low altitudes, you will have cumulus clouds. They are mid-altitude clouds and they are very, very dense. So usually if let's say you see cumulus clouds, it's probably not going to rain. Okay, if it rains, it's just going to be, I think, a drizzle. And for high altitude clouds, cirrus clouds, essentially they're wispy, they're less dense, they kind of look like this in the sky. Cumulus, it looks like this, like your child's drawing. Yeah, literally. And in the high altitude, there's also cirrocumulus clouds. They are also known as cotton wool. Cirrocumulus. And they look kind of like this. And for cumulonimbus clouds, they are at very, very low altitudes. Why is that so? It's because cumulonimbus. Okay, so it's because it's gonna rain, so they are very, very low in the sky, so that when it rains, because essentially cumulonimbus clouds, they are actually very, very dense and they are very, very heavy, so when it's gonna rain, they will just sink down to the low altitudes, kind of. And they are UFO looking, so they kind of look like this. Although you can't see this part, because this part is, up in the sky, and then you are not up in the sky. So it's anvil shaped, extremely dense, slightly grey because it's ominous. Oh, it's gonna rain. So this is raining clouds, usually for convectional rain, which I'm gonna talk about later in the fourth point. Grayer clouds also show that they are going to rain because there are more water droplets, and you know water droplets carry with them dust. So this dust is what makes the clouds grey. And clouds that are much lower, they are very, very heavy with water vapor. Next, for low altitudes, Nimbostratus and Stratus clouds, they essentially you can kind of predict that there's going to be potential rainfall. And then low altitude also has stratocumulus, autocumulus, cirrostratus. You can all Google them up to find out more. So, but those that I've drawn out for you are those that are more prominent. So for cloud formation now, let's move on to cloud formation. Okay, cloud formation, there are a few key steps that you need to know. Cloud formation, firstly, evaporation of water happens, and then water vapor in the air, which is warm, the warm water vapor in the air, which was from the evaporation, starts to rise. Water vapor is cooled rapidly as it rises, and as we move higher up the atmosphere, temperature falls and relative humidity rises, because the air is cooler and is less able to hold water vapor. If you're not sure what temperature and relative humidity are, head over to my previous video where I talk about the relationship between temperature and humidity, which is essentially the foundation of geography that you have to know. After the air is cooler and is less able to hold water vapor, it becomes very, very saturated at the upper atmosphere. And saturation occurs. If you're not sure what saturation is, head over to the previous video. Saturation occurs and water vapor ceases to exist as gas as it changes back to water because of condensation. Water droplet condenses on dust particles, forming condensation nuclei, and different water droplets and nuclei bump into each other, which is a process called coalescence. After that, clouds are formed. You must know that for condensation to happen, there must be dew point temperature. That's a very, very important thing to note. Alright, so now let's move on to cloud cover's influence on temperature. This is where I'm going to start drawing diagrams, and it's very, very important for you to understand it. So if you don't understand, please comment in the comment section below. So for cloud cover's influence on temperature, take a few seconds to think about what this means. Okay, so in the day, this is how it happens. There is a cloud. That's how cloud cover influences temperature. And and the cloud reflects part of the oncoming solar radiation from the sun. So it's kind of like a blanket that traps heat. The clouds. And then heat from the Earth's surface, which is this line here, it goes up and then it is reflected back on the ground. Those clouds which are white, they help to reflect the heat, and these clouds must be dense. And then besides these rays, there are also rays hitting the surface of the Earth, and the ground absorbs heat. So at night with clouds, heat is released from the Earth's surface at night, and when there's a cloud, it hits the cloud and it's reflected back to the ground. That's why sometimes you notice that on a cloudy day, in the day it's very cooling, but at night, if let's say there are clouds, it's kind of hot. How about without clouds? For without clouds, in the day, temperature rises up very quickly. And in the night, heat escapes easily. As what I've said just now. So, to sum up, the presence of clouds means lower temperatures in the day, higher temperatures in the night, and with the presence of clouds, there will be smaller diurnal temperature range. Diurnal essentially means the difference of max and minimum temperature. So for the presence of clouds, you can also link it back to the absence of clouds, which is the opposite of presence of clouds. You can see it in the case study of a desert. That's why deserts are very cold in the night and hot in the day. It's because deserts, they don't have clouds, so in the day, the ground is heated up very quickly, but in the night, the heat is lost very quickly. That's why the diurnal temperature range is very, very wide. Okay, going back to our document here. The kind of like measuring thing that you can use for measuring clouds is the Octave Scale. So the Octave Scale is essentially like something like this. Please see your bottom left hand corner of the screen. And if let's say clouds cover here, and then there will be a measuring kind of system to see what is the range of the Octave Scale 1 to 8. That's why it's called octave, because 8. Next, let's go on to rain. So there are a few different types of rain. Essentially, we'll be looking at convectional rain and relief rain. So give me a second. Okay, so rainfall is a form of precipitation, and clouds that are too heavy to be suspended, they fall as rain. Precipitation exists in the form of snow, hail, rain. Yeah. So as I said just now, there are actually 3 types of rain: convectional, relief or orographic rain, and frontal rain. But we are mostly focusing on convectional and relief rain. For convectional rain, here I'm going to draw a diagram again. Convectional rain. You see that there's a sun here, there are clouds here, and this is the Earth's surface. So solar energy comes down and the sun heats the ground up, and the ground heats up and heats up the air near the ground too. So the warmer air that is being heated up rises, and the air reaches dew point temperature, and when the air reaches dew point temperature, cumulonimbus clouds are formed as water droplets accumulate, and then water droplets accumulate and fall as rain due to the gravity. Next, talking about relief rain. For relief rain, it is like this. Relief rain only most of the time occurs with a mountain. So there's a cloud here, this is the sun, and the prevailing wind direction is this side in this case. And it's always near the sea, and when the sun heats the sea up, the water reflects the heat energy in the day and heats up the air above the sea. And after it heats up the air above the sea, moist warm air from the sea rises, and then this warm air cools, condenses, and then clouds are formed. And remember, these clouds are only existing on one side. It cannot be existing on the other side. So the air rises on the windward slope and forms clouds. When these clouds are heavy enough, they will fall as rain, and this remaining warm air drops down over the high ground, losing temperature and increasing amount of water it can hold. That means that this side has little rain, this side has more rain. That is why this side experiences something called the rain shadow. And you can see that in some places, one side of the mountain is more green and looks more luscious, which shows that the dominant prevailing wind direction is from that side. While the other side, which is called the leeward slope, although it might be green, it might not be so luscious. Thanks for watching, and for a comprehensive set of notes, head over to Carousel and PM me the discount code in bold here to enjoy a $5 discount. Till the next video, see you!